Welcome to Training Tuesday, and thank you for joining our webinar today. My name is Drew Roby, and I will be filling in for Heidi today. I am the Marketing Program Specialist here at Dayton Superior, and I would like to go over a couple of items before we get started. I wanted to remind everyone that you are muted so that the presentation can be conducted without any outside disruptions, but please feel free to provide us with any questions that you may have throughout the presentation, and at the end, when we will have our short Q&A session. You can provide those questions through that chat or QA functionality in Zoom. As a reminder, each of our webinars are recorded and placed on our Dayton Superior YouTube channel, as well as our DaytonSuperior.com website. Just search Training Tuesday and you will see the link to the past webinars. Today's presentation is intended for training purposes only, and you can find technical and product information mentioned in today's training on DaytonSuperior.com, like you see there on the screen in blue. Did you know Dayton Superior is the leading provider of engineered solutions and products for the concrete construction industry? We specialize in accessories, chemicals, and forming, and have proven results through our Simon's Forming Shoring portfolio with systems that are adaptable, strong, and save labor costs, and through our concrete repair and restoration products specifically formulated to meet the design specifications and new construction or retrofit repair needs. In addition, we provide bridge deck, rebar splicing, precast and tilt-up construction engineering solutions, products, and training geared for your needs. Today's presentation is about bridge deck and reviewing the plans to calculate estimations for the accessories required for the job. Here to present for us is none other than Chuck Hoke, our National Training Manager. Chuck is our subject matter expert for both our customers as well as all of our internals here at Dayton Superior. He has clocked in nearly 50 years in the concrete construction industry, and 30 of those have been at Dayton Superior. From navigating sales and accessories, forming and chemical product lines, Chuck's been there and done that. He has expertise and degrees in business and civil engineering, making him the guy to solve any hiccup. And he's here to expand our knowledge on bridge deck today. So take it away, Chuck.
All right, well, thank you, Drew. Hi. Good afternoon, everyone. We're here today. We're going to look at bridge deck plans and accessories. This is kind of a culmination of all of the presentations that we've done on interior, exterior, etc. So what we are going to be talking about today is we are going to be looking at bridge deck construction. The generalized construction of a true project here that we're going to be talking about is one that is actually bidding here in a couple of weeks here. But we are going to talk about cast in place concrete, whether it be precast steel, wood, or basically concrete being precast or cast in place, supported concrete steel girders or concrete girders. We're going to talk about the sheeting, the joists, the ledgers, cast in place, SIP decking, etc. But primarily what we're going to be looking at here is overhang brackets, spacings, how to calculate it, how to use the tools that are available for you to actually calculate how many brackets you're going to need, and also any of the other accessories that go along with it. Chemicals that can be also used for this, such as curing compounds or any other type of finishing aids. For a lot of the dealers out there right now, the curing is actually, a lot of the bridge construction is dependent upon DOT specifications, what they will allow. So we will lay hold to what is out there, different methods and policies and procedures, but a lot of that refer back to your DOT guidelines for a lot of this information. And obviously, we do have a full engineering service, and we will talk about that a little bit in this presentation, because we are going to show you how we actually come up with the calculations and the figures, where we get them from, the plans for this job, for this project. So, excuse me. The project is a New York State DOT project here. I resort back to where my roots came from. I started out working as a dealer up in upstate New York, and so I was very familiar with the DOT up in New York. So I went back to a job here, and this job actually bids here in a couple of weeks here. It is project D 265. 265. Excuse me, 265. What we're seeing is that this project here is in a couple of Shenango and Schoharie counties. And the project here, what we're going to do is we're going to review the deck plan sections for it. The overall length of the girders, the girder spacing, the deck thickness over the girder, the bridge deck width, the top. Then we're going to talk about the rebar location, you know, where the rebar sits in the deck. And there's a couple of characteristics that you must know how to do. One is you're going to need to know how to read plans to actually get to, if you to get really comfortable with this, you have to understand the plans and the application. So let's get started with a lot of this. If you get the opportunity to take a plan reading class, I highly recommend it. If you already know how to read plans, this is just going to be like second nature for a lot of it. Just going to kind of put all the ducks in a row for you. So basically when you get a set of plans, this set of plans, I believe, is somewhere in the neighborhood of about 190 pages altogether. The structural section of the plans you want to go through, and you want to go find the notes section, because what you're going to be looking for, there are some, you got to go through and read through a lot of these notes, and a lot of them will not pertain to anything that we do. But because the plans have a couple of denotations on them, you're going to be looking at superstructure slab notes. Okay. Now, this is one little section up here, and the provisions of this content basically will tell you how they are going to form the bridge deck up. And on this one here, you got basically two options of the three that the state will allow. One is actually removable wood form. You can use regular concrete forms, or you can use SIP decking. And SIP decking is basically corrugated metal decking, which is typically provided by others, but you see in New York State, it's quite commonplace across the country for people to use SIP decking. We're starting to see other avenues come through where people are using concrete plank. So that'll be coming up as a fourth option, probably for a lot of these states. What you're also going to be looking at is, and on this one, this job here was kind of special because they have this metallizing note. And you read down through the metallized, it just tells you that they're going to be coating the girders, the studs, within the nuts and studs, etc., all within this structure here. And they're going to coat it before they put it in place. And what's imperative here is there will be no welding to the metallized or galvanized surfaces. Now, a lot of times you have to worry about, well, that means I can't use a half hanger. So you can't use a C24 half hanger because you cannot weld to the girder. So those hangers are now taken off the table for you to be able to use. So now you got to look at either a wraparound hanger or like a C25 type that would actually connect to the Nelson studs, etc. But they're going to use like a friction connection. So you keep that in mind. And we've got basically here the bridge deck that we're looking at. This is the section view, cross section view of the deck. As you can see, it is basically approximately 41 foot, 42 feet roughly from out to out. You can see that it has a 2-foot overhang on it. You will see that you have 5 girders here, so you have 4 bays. On this drawing here, you're also going to see some of the rebar sizes, the clearances, the coverage, and everything else. And what you're primarily looking here is this information right here. The other information that we're going to be looking at is on the same page. Is going to have a steel beam designation. So here's a picture of the steel beam. As you can see, everybody says, well, why do we have to see the steel beam? Well, you know, there's a lot of pertinent information on here, because you look at this and you've got, you know, the first thing you want to look at is you've got 218 feet in overall length. So roughly, for estimating purposes, I would round that up to 220. Just, we're only putting an all estimate together here. So we want to get real close, but not exact. So we're at 220 feet roughly in overall length. Top beam flange, because this is where your hanger is going to go, is your top beam flange, which is the top part of the beam, the flat part, that is 21 inches wide by 2 inches thick. Okay, so imperative, because that's going to be the size of the hanger that we are going to have to fit to this project. The other item that we need is the web dimension. Now, the web is the distance between the top beam flange and the bottom beam flange. And this web is quite critical because it tells you how big your overhang bracket can be. Now, you're at 33 3/4 inches. A very common beam size for New York State is a 33-inch girder. The reason I know this is because of my history, but the one thing that you have to look at is a C49 bracket only works with a 30 to 50 inch. So you have to adjust your bracket to a C49S style bracket, because you got to have hardware, forming hardware to go with up to the top of the girder flange. And usually you're looking at about 6 inches of concrete form work on top of this. So realistically, you need your overhang bracket to be about 26 inches, 26 inches at the max, because that would actually put the bracket right in the center of the web. So you're going to have to adjust your bracket and your spacing to go and look at, you know, your C49S style overhang bracket because of the size of the beam. So realistically, when we get to the drawing, I'll show you what we're going to, this is kind of an oversimplification of how they actually did it. For a 21-inch beam flange, I would remove the pipe and actually kick the bracket down small. We'll show you that when we get to the drawing section. But for all practical purposes, we're going to start with the C49S, and you will find this on the page in the handbook. Now, the handbooks right now are actually being reprinted or basically being recalculated. OSHA just came out with here just a few months ago a replacement. They actually added a weight configuration to the overhang bracket. So we now have to have an additional calculated weight factor on the overhang bracket for somebody leaning against the guardrail, having to worry about them falling over, etc. So it's a little bit more than a live load. It's an extra weight that we didn't calculate in with this original design. So these calculations on this table will be changing here shortly. And what I changed everything to is to the new specification. But we're going to show you how to run through to go get to this. Your second step, once you've got the C49S, find your concrete thickness. Okay. Now your concrete thickness typically comes from that section view. Now I like to use a 6,000-pound hanger all the time. I'm kind of funky like that, I guess, is I like to make sure that I'm using the strongest hanger that I have available, because that's going to mean I'm going to maximize my hanger and my overhang bracket space. So I will use a 6,000 pound hanger. So that means I am going to use a C68 hanger, wraparound style hanger, because it doesn't require any welding to the girder. It will have to be hot dip galvanized, which is quite commonplace within the marketplace. So what we would do from there is you're going to have to determine the weight of your finishing machine. The weight of your finishing machine has to come from the contractor. Okay. And it varies by what type of machine they would have. Like if I had a C450, a Gamaco C450, I believe the weight is going to be somewhere in and around the 1,100 to 1,200 pound load rating. So by looking up that, or if I'm using a 3,300 machine or 3,600 machine, that is actually going to be a heavier wheel load. It's going to be about 1,700 pounds per wheel load. So either way, you're going to come down through and find out here what you have to run for your calculations. Where your crisscross, where you had your hanger intersection, to where your blue line come down through your hanger bracket spacing on this one here. Typically under the old specification would be about 4'3", but with the new OSHA requirements that have just been added to it, it actually takes it down to about 3'6". This is one of the, like I said, a brand new specification. It just came in. Your best bet to actually, if you're running calculations and need that calculation, our engineering group can actually help you with that answer. So with that spacing at 3'6", so I've taken the overall length of the bridge here, 220 feet, divided by the 3'6", give me 63 pieces per side. I always add one to start with. You always have to start out with one to start your spacing of brackets. That means I need 64 brackets per side. So 128 brackets total for this structure. Your BOHB is your standard C49. You're just going to adapt it to a C49S. You are going to have a guardrail on it, so you're going to have roughly 128 of those posts. And you're going to have extensions, possibly. Some contractors will use them, some won't, and I'll show you the drawing that we've done up. We actually included that on it. It isn't really necessary on this job, but it actually makes life a heck of a lot easier for guys walking the length of the bridge deck, that they don't have to have any hit those knee knockers where they have the 45-degree brace coming off the bulkhead form coming down. So as I mentioned, I'm going to use the C68 4AB galvanized hanger, 6,000 pound capacity. It's my preferable hanger. I use these for many years with tension zones on a lot of structures in New York State with weld-on hangers, but in this case here we can't weld, so we're stuck with the C68 4AB. And I would recommend getting the hanger early, so that as soon as the beams show up, you can install them on the girder and let the SIP decking guy cut around the hanger. If you're an SIP guy on this phone call, I apologize, because I know it means a lot more work for you cutting your angles, etc., and getting them attached. So you're also going to need coil bolts. Your B14As, you're going to have 128 of those for this project. And possibly, and it's one of those things that may or may not be on the job site, you may need 200 to 230 cradle heads. Most of the time, the contractor owns the cradle heads, because if the finishing machine goes out, the cradle heads go with it. We do have somebody in the chat.
Can everybody see our screen?
Your screen share.
Yep.
Yep.
Good to go.
Okay, thank you very much. So with this information, we actually take out our bridge deck information sheet. You can find this on site on our website, DaytonSuperior.com. Just go to bridge, go to the resource page or services page, go underneath engineering, and it will give you the option of coming up with bridge deck. This sheet will come up. You can actually then fill out the information and electronically send it off to our engineering group. Now, what our engineering group will typically take this is a billable item because this can be turned into the state by the contractor as his engineer work for his design of his bridge deck. So this is something that is actually billable from our dealer from us to the dealer and the dealer to the contractor, and it'll be part of the package that is given to the state. So we will actually create a booklet. The booklet actually comes with this great cover. It's a great little piece that you can actually submit right to the DOT with all the pertinent information on it. And you will come up with, it'll include all of the cut sheets for all of the different products, including the C68 hanger, coil bolts, overhang brackets, and all the accessories that go along with it. But this here is the part that is actually most important. This is the calculation summary for this job here. And if you run through, you can see where we actually calculated out to everything to run out at 3 foot 6 inches. And we run calculations based off the fact that we are using SIP decking, so we do not have any interior formwork, but just the exterior on here. So typically these are, if we're just doing the exterior, it's about 2 pages. If you're doing an interior and exterior, only a single overhang. No, we have some.
Nope, those are just from before.
Okay. So with that being said, here's the drawing that we've actually come up with it. And now with the finishing machine that we put in place here, it's probably a lot heavier than what we typically would have. And to be honest with you, that actually, the finishing machine is actually about 75 to 80% of the weight that the overhang bracket has to support. So realistically, with this small overhang, it's granted it's 16.5 inches in height, the concrete, and only 2 foot from the center line of girder, but with the girder being 21 inches, you only got about 11 inches of beam on the half side. So you're talking about 13 inches of concrete. So you're talking probably 220, 230 pounds per linear foot of concrete. But most of that that's being supported here is the finishing machine going over running on the top of that cradle head. So we would recommend getting a drawing here so that this is already calculated out. You can see the dimensions on the overhang bracket. I would recommend setting the overhang bracket prior to actually hanging it on the bridge deck, just because life gets easier if everything fits just the way it's supposed to. And I like to use 4x4 for my joists under my plywood for the simple fact that they do not roll. If you use a 2x4, you stand it on edge, they have a tendency to roll over. So from that, we go to all the different accessories that we have within the booklet. As I said, the calculations, the coil threaded calculations, coil rod nuts, etc. So let's look at bar supports. Bar supports are a little bit more creative here in it. The bar supports typically are developed here. I pulled just this little section. We're going to blow up just the one section here. You are going to have your overall deck thickness, 9.5 inches here. You're going to have the bottom cover of concrete from the SIP decking to the bottom of the rebar. And you're gonna be given the top dimension, top cut that you're looking at. Now, the one thing you want to look at here with this job here is all the rebar in here was specified as a type 4. Or I should say a number 4 bar, which is a 1/2 inch bar, all hot dip galvanized. Except for this one bar, the hook bar that actually runs right here. And then around. Okay, now this hook bar here is a number 6 bar. And it's basically 10 foot long. So from the edge of the bridge to 10 foot in, you have a number 6 bar. That's going to come into play here, coming up here in a second. You'll see why that's important. We come back with deck thickness of 9.5 inches, bottom cover of 1.5 inches, top cover of 3 inches. If you're using a 4-4-4-4, which was what the main bar is for the main center line of the bridge, you're going to have a 3-inch slab bolster upper for the center line section of the bridge. On the alternating where we have on the exteriors on the fascia, this is kind of an oddity. This is one of those that you really have to pay close attention to. The alternating 6 bar would actually require you to actually use a 2 3/4 inch slab bolster up. Now, as we said, it was galvanized rebar, so we got galvanized bar supports. Your option with this is if you don't want to use galvanized bar support, you can use all plastic. So the bottom is 1.5 inch coverage on the bottom. So it's 1.5 inch slab bolster upper, whether it be galvanized or plastic, it's up to you. And since it's going to be running longitudinally on the beams, you're going to have 4 bays. So you got 5 beams, 4 bays. You're going to have 3 rows per bay because you can't fit 2 in there without having more than a 4-foot span between bar supports. So it's roughly, you're going to have to put 3 in there. If the contractor doesn't want to do it, it's always best. You can always come down with your estimate. It's hard to go up and try to give somebody, tell them he's got to have a little more. So typically you're going to look at about 2,640 feet of 1.5 inch slab bolster upper. Now this takes care of the bottom mat. The 3-inch slab bolster upper, because it's going to be running transversely across the slab, you're going to have 220 foot divided by 4, because 4-foot spacing on the overhang gives you 55 rows. You're going to have roughly 56 rows. And you got 25 feet going right down the center of the bridge. So that's going to give you 1,400 feet of 3-inch. For 2 3/4 slab bolster upper, you're going to need roughly 1,120 feet. This is kind of an oddball the way they well, this was all calculated and because of the extra bar being put in there with the hook on it. And that's going to come into place here when we go to do our overhang calculation for what we're going to put on the bridge overhang bracket. Now, typically, I only support the bottom bar. I don't have to worry about the top bar because that's taken care of with this, with the calculations of the 2 3/4 or 3-inch material. So the bottom, since it's going to be on a wood form face that's going to be stripped, I like to use all plastic material. And because the bridge deck itself was 16.5 inches, I'm taking off 5.5 inches because of the beam flange thickness of 2 inch, the haunch distance of 2 inches, which is minimum in New York State, and the bottom cover of 1.5 inches gives me 5.5 inches. The slope of the deck was roughly 2% per foot, so that's roughly because we're roughly 3 foot on the overhang. From center line of girder out, gives you about 5¼ inch. Actually 5¼ inches, plus or minus. So what we're looking at is and you got a number 6 bar that's being draped in and around the corner edge. So that is a 3/4 inch bar. So I'm going to deduct that from the 5¼ to give me 4½ inch. I typically like to space my individual chairs at 3 foot on center. So I'm going to need 155 pieces for both sides of the deck. I prefer, like I said, all plastic because one, if they fall over, it's not going to show. And also because it works with black, epoxy, stainless, and in this case, galvanized rebar. So with that in place here, that gives you your deck supports, how to calculate deck supports and your hangers, bridge overhang bracket, your coil rod, etc. All those components can typically get put into it. So this all comes out of the bridge deck booklet. The resources are for you available on our website here for technical data sheets, handbooks, e-marketing pages, contacts. You got customer service, technical, our engineering, and obviously our training group and your sales reps can all be found online also. Just refer back to DaytonSuperior.com. So if you have any questions, and this will be posted here today or tomorrow online on our YouTube channel. So if you need a revisit it, or if you have questions, you can get a hold of myself at training@DaytonSuperior.com or contact me at truckhope@DaytonSuperior.com, and we'll get you these informations. If you're looking for more training on this or dedicated training just for you guys, once again, scan that QR code on here and it will actually take you to the Training at Dayton Superior site where you can actually log in to request training. Now we got a couple of questions here.
Yeah, it's mainly the same one. We got a couple questions about sharing the slides. So we don't normally do that, but we will send follow-up with a link to the video so you can share the video. But those slides we don't share out. So we'll send you that follow-up so you can use that link, and like Chuck mentioned, that will be out soon.
Right. So if there's no other questions.
As of right now, I'm not seeing anything else. If you do think of anything, let us know.
All right. Well, we want to thank you all for your time and for everybody to have a superior day. Thank you very much and take care.